today we are gonna solve the problem of the day for 14th January. Actually, I have solved this problem, but due to some error, I don't know why uh, the video didn't get saved. So I am again explaining you the entire problem. So the problem is find the prefix common area of two array. So this is a problem in which the question is, we are given two arrays, right? And we have to return our array C, in which Ci is equal to the number of common element between A and B till I. I hope you understand that. So that 2 means there are two elements, which is 1 and 3, which is common in A and B till the ith index. Okay, so let's say this example. Okay, so what should happen here is C is equals to, so for C0, we have to consider all the indexes before 0, so which is C0 before or equal to 0, and we have to check how many elements are common in A and B till 0. So there are no element common, so C0 is 0. For C1, we have to check how many elements are common in A and B. So there is one element, which is 3, and for I equals to 2, there are all three elements common, so answer should be 3. So this is our output. So yeah, I hope you understand the problem. Talking about the native approach. So the native approach is the most basic approach which we are thinking at the first place. Okay, so how can we solve this through native approach? So we iterate through range of length A to create C, count the common integer in A and B for index I is equals for index less than equals to I. Now I iterate through A with J and count if AJ is present in B. Okay, right? So the time complexity is, as we have to use three loops. The time complexity is n cube, space complexity is n. So this is the native approach. So can we do something better? So yeah, we can use set or hash map. So what we can do is we can take two sets, set 1 and set 2, set 1 for A and set 2 for B, and while iterating at I, we can check that if AI is present in set 2. So the property of set is, we can so insertion in O1 and searching in O1. So this is the property of set. Okay, so we can check that if 2 is present in set 2, no. If this 2 present in set 2, no. And third case is if both AI and BI is equals, so yes. So this is the case. So we will return 3 because till here we know that two cases are common before I. So we have pre-calculated this in the iteration, and we have also we can check that one case is also equal, so which is 2 plus 1 is equals to 3. So this is the solution. This is the proposed solution with hash map. The time complexity is we have to iterate through this and searching and insertion in O1. So time complexity is O(n). The space complexity for making the C, the space complexity is O(n). So this is our code. So set1 is set2 is set, previous is 0. Okay, previous is basically the previous C. Answer is the answer for I in range length A. Count is count if AI is equals to bi count plus 1, else if AI in set 2. So if this in set 2 count plus 1, if bi in set 2 count plus 1, set 1 dot add AI, set 2 dot add AI, answer dot upon count plus previous, and we will make previous increasing the count, and we will return the answer. This solution have beated the 70% of the time complexity. So this is the most optimized solution. As we can see, the 100% time complexity is also the most optimized solution. Thank you guys for watching this video. And sorry guys for this, because due to some technical issue my previous videos got deleted, so I have to recreate this video. If you have any question, you can feel free to ask in the comment section. Thank you.